So now we're going to talk about what kinds of arithmetic or algebra we can do with matrices. So suppose we've got some matrix A, and let's say it's 2, 1, 0, minus 1, minus 2, 3. Okay, so A is a 2 by 3 matrix. One thing that I can always do is I can look at the scalar multiple. So scalar multiplication means just multiplying by a scalar or number. And the emphasis is that we're not multiplying by a vector or some other type of matrix. We're just multiplying by a number. So if I want to look at some constant C times the matrix A, then the ijth entry of this would be C times the ijth entry of A. Okay, so what does that mean? Well, if I want to do, say I take C equal to 2, then CA for this A that I wrote in the previous line would just be multiply every entry of that number, entry of that matrix by 2. So 2 times 2 is 4, 1 times 2 is 2, 0 times 2 is 0, negative 1 times 2 is minus 2, negative 2 times 2 is minus 4, and 3 times 2 is 6. So it would look like that. Okay, so you can always scalar multiply any matrix by any scalar. We can also talk about A plus B, but for this we need to make sure that these guys are both the same size. So I might write this as something like saying A and B are both 3 by 2 matrices or something. They're both the same size. They're both matrices with the same dimensions. And the way it goes is that the ijth entry of A plus B is just the ijth entry of A plus the ijth entry of B. So this is the simplest, most straightforward thing. You've probably already seen this before, adding vectors. Whenever you add them, you add the first coordinates together, and then the second coordinates together, and then the third coordinates together. It's all done entry-wise, right? So suppose I've got my same matrix A as before, and I've also got B given by 8, 5, 17, 4 minus 6, 12. Then if I want to do A plus B, I'm going to be adding 2 and 8 to get 10, and then 1 and 5 to get 6, and then 0 and 17 to get 17, and then minus 1 and 4 to get 3, and minus 2 and minus 6 to get minus 8, and 3 and 12 to get 15. And that would be how we add these two matrices together. And so now we also know how to subtract. So if we did A minus B, this is the same thing as A plus negative 1 times B. And so this would be 2, 1, 0, minus 1, minus 2, 3, plus, and then I do negative 1 times B, so I have minus 8, minus 5, minus 17, minus 4, 6, minus 12. And then you can work out the sum on your own. Now that we know how to do scalar multiplication and addition and subtraction, we can talk about a linear combination. So linear combination means everybody gets multiplied by a scalar, and then you add it all up. So if A1 and A2 and so forth, say we've got a bunch of these things up to AN, if if these guys are all the same size, then C1A1 plus C2A2, so we add each of these guys with some coefficient C. And so this might be written I equals 1 to n Ci AI. This is called a linear combination. So in the previous step here, I had a linear combination of A and B with coefficient 1 for A and coefficient -1 for B.